Let us discuss three-way merge. So over here in the diagram, we will consider the case that we have a master branch which already has two commits, and this is the timeline where we have noted down three instances of time t1, t2, t3. So currently we are at instance t1 and we have two SDETs, SDET1 and SDET2, who wants to work on these specific features. So let's say SDET1 wants to work on feature/login and SDET2 wants to work on features add card. Now what they will do is they will pull the master branch on the local machine. At time t1, both of them cuts a new branch. So SDET1 cuts the branch with name feature/login and SDET2 cuts the branch feature/add card. Now as part of the work, let's say that SDET1 made two commits within his own branch. So he made a commit 3 and commit 4 in his own branch, and SDET2 also made some new commits onto his own branch, which is feature/add card. Now both of them wants to merge the changes into the master branch. Now let's assume that SDET2 is the one who was able to merge his changes into the master branch before SDET1, and this is happening at time instance t2. Now when this is happening, Git will check whether there is any new commit in the master branch. So as we can see, there is no new commit into the master branch yet. So this seems to be the case of fast forward merge, where there is no new commit after the ancestor commit, which is this. So there is no new commit after this. So what simply this will do is it will just move this header of the master branch on top of commit 6. So this is how the master branch will look like. It will have two more commits in it, which is commit 5 and commit 6, which came from the branch of SDET2, and the head of the master branch has now shifted from commit 2 to commit 6, which is commit from the SDET2 branch. This has all happened at time instance t2. Now SDET1 also wants to merge his changes into the master branch. What he'll do is he will first check out the master branch on his local, pull the latest changes from the master branch to his local machine at that point of instance, which is now at time t3. So he will see that there are some new commits after the ancestor commit, which is commit 5 and commit 6 are the new commits. And now when SDET1 will try to merge his branch into the master branch, Git will use three-way merge. The criteria to decide which merge strategy to use depends on whether there are any new commits after the ancestor commit or not. In this case, we have some new commits after the ancestor commit. So that's why Git will use three-way merge. So the question arises, what exactly will happen as part of this three-way merge strategy? What internally within Git will happen for this merge request to get complete? And why do we call it as three-way merge? Let's see that. So there are a couple of things here which will happen due to three-way merge. First, Git will create an automatic commit object and place it after this commit 6 in the master branch. And for that automatic merge commit, commit 6 and commit 4 will act as the parent commits. And why do we call it as three-way merge? Because this ancestor commit, the latest commit on the master branch, and the latest commit coming from the feature branch gets involved in creating this new automatic merge commit, and the complete picture will look like this after the merge. So now over here we can see that this auto merge commit object was created by Git itself. It was not created by either from the SDET2 or SDET1. This is something created by Git itself, and it has moved the header of the master branch from commit 6 to this auto merge commit object. And as I said, these three commits, commit 2, commit 6 and commit 4 were involved in creating this auto merge commit. That's why we term it as three-way merge. I hope you enjoyed the session today and would have learned something new. If you did, please subscribe the channel and do share the content with others as well.